twice as much fun today.
Are we doing something?
No.
Oh, the double minion.
Oh wait, ready? Double dancing minions. Now, Friday, grades are due, right? So if you need to turn stuff in, Friday's the day. Check Skyward to see if your grade is passing, all that good stuff. We are going to have a quiz on Friday over this stuff, so it's not that bad. Today we have some notes, but it's very similar to the last 2 days, so it's not too much, I promise. Okay, now, let's look at this. This equation, does it have a negative out front? No, so that means it does not do what? What does the negative usually make it do? Reflect. So, mirror, flip, reflect. Okay, but this does not reflect, so it's still going up like a V. Okay. Now, what does that 1/2 mean? So think of like an accordion like this, or taking some dough. It's a vertical what? Stretch. Vertical stretch. Back it up. Vertical what? So is 1/2 bigger or less than 1? Less than 1. So instead of saying vertical stretch, it's a vertical compression, but vertically. Take that like this. Vertical compression. Okay. So if you vertically compress it, it's gonna look what? Gordita. All right. It's gonna be a little wider. All right. So gordito. All right. So again, if it's greater than 1, vertical stretch, it'll look narrower. If it's less than 1, like this, vertical compress, a little wider looking. Okay, so let's go ahead and write that down. Just by looking at this equation, I see that number. I know it's a vertical compression. Okay, now, second thing, if you have a number inside the vertical lines, we know insiders are what? Insiders lies. Everyone remember this from yesterday, day before? So that means this +3 is going which direction? So it's like a -3. So which way is that? Left. Okay, so please remember, in here is horizontal, left or right. And +3 means left 3. Okay, so it shifts left 3. And then what about vertically? What do you notice out here? There's no number there, right? So if it doesn't add or subtract anything, it's still at 0, okay? So here's the deal. If I asked you, what is the vertex? Okay, what's the h comma k, like we talked about the other day? What is the h value that we just talked about on the inside? Since it's left 3, okay, and since it's a liar, it's a -3 for my h. And then since there's no vertical shift up or down, what's my k value? 0, okay? So remember, the opposite of this, and then whatever's out here, that's your h comma k, that's your vertex. So I'm going to do a quick sketch. If I were to sketch this at -3, 0, yes, except that here, I can't see it because it's upside down. Something like that, yeah. Now, when you see that 1/2, if your a is 1/2, remember that's rise over run. So it means you're going to rise up 1, run 2. And the other way, rise up 1, run 2. And you get this wide looking absolute value function. Shifted left 3, vertically compressed, so it's a little wider, okay? Now, we did 3.1, today we're doing 3.2, absolute value key features.
Yes, I love the God. Can I go to the restroom after the notes?
And then there's this. Hopefully, it should be kind of short. Okay. So again, if y'all can look up here, as usual, if you don't have headphones in your ears, I don't have to say it a million times, and then it gets done faster, right? So everyone looking up here. Please. Now, this is not on your notes, so just look. All you gotta do is look and absorb, like a SpongeBob. Okay, now, this is called the parent function, because everything comes from the parent. It's the originator. Okay, so that is called the absolute value of x. You showed me, so now there you go. Okay, now, if I were to graph this, if I go into my calculator and I press ABS, parentheses x, graph, and then I hit Control T, I can get a table. Okay, now, is that you? Is that me? Not me. Okay, so if I got the table, it would be these points. And if I were to plot these points, it would look like this. Now, if y'all weren't such helicopter enthusiasts, you might have a ruler, but it's okay. You don't even have this on your notes. So now, you know what it looks like. That's the parent function. Now let's talk about domain and range. Okay, domain is what variable? X. Which direction is domain? Left to right. Okay, so the domain here, if it goes, see the arrowheads? Forever to the left, forever to the right. What is forever? What does that mean? Where's it going? Negative infinity. And then to the right, positive infinity. Now this is called interval notation, right? Right? So here's how you write it. And notice the range. The range does not go down forever, right? It stops right here at 0. And since it's not an open circle, you have to include 0. So do you notice how there's a bracket next to that 0? It includes 0, and then it goes up to infinity. Okay? Now, there's another way you can write this that's kind of like a shortcut, and it's like a weird looking R. That means all real numbers. Okay? So if you ever want to do a shortcut of saying negative infinity to positive infinity, you write this weird looking R, that's all real numbers, okay? Now, where's the vertex? 0, 0. What's another name for that 0, 0 point? The origin, okay? That vertex can either be a minimum or a maximum, okay? And then your x-intercepts, okay, sometimes it crosses once, sometimes it crosses twice, sometimes it doesn't cross at all, okay? And in this case, the y-intercept is also the x-intercept. They both cross at 0, 0. Okay, enough of that. This is what's on your notes, okay? Actually, one little thing. Can you spot the error on your paper compared to what's right here? It's like in the first sentence. Okay, yours says ACD, but it's supposed to say AHK. So, I mean, I know yours says C and D. You can X that out and put H and K. Okay. We've been using H and K. Other people use different letters. I tried to fix all that, and oops. But here we are. So, fix that real quick. Now, H and K is your vertex, just like we did on our warm-up just now, right? And then, y'all know a max is at the top, minimum is at the bottom, hopefully. And then you know symmetry. Or did y'all know this? Axis of symmetry is always x equals a number. It's a vertical line. So it's x equals the x value of the vertex, the h. X-intercept crosses the x, y-intercept crosses the y. That's pretty much it, okay? So with that information, step 7 says to identify the domain and range. All right, here we go. Let's do example 1 here. Kind of like the warm-up. What does that negative sign mean? What does that do to the graph? Reflection, okay? It reflects downward across the what? X-axis, okay? Okay, so that negative means it reflects across the x. Now, what does this 1/2 mean? It's a vertical something. Which one? Compression. Why is it compression? which is less than 1, right? So if it's smaller than 1, it's going to compress, small. If it's bigger than 1, stretch, okay? So it flips over, it's vertically compressed. Now this -5 is inside, so which way is that going? If it is 1, there's no stretch or compress. Okay, but why is it left? But inside there's lie. Remember that? So inside, think of it as opposite, okay? What's the opposite of -5? +5, so which way is that? To the right 5. Okay, what about the -3? Which way is that? So this one's vertical though. So down 3, okay? So that's right 5, down 3. Insiders lie, outsiders don't lie. Okay? Insiders are horizontal, outsiders are vertical. Okay? So let's go ahead and write this down, please. It reflects across the x-axis because of that negative sign. It's a vertical compressed because of the 1/2 is less than 1. Right 5 because insiders lie. Down 3, outsiders do not lie. Outsiders are trustworthy somehow.
Orange plus -1/2.
So when you're doing the stretch or compress, you ignore the negative sign. The negative is just for the reflection. The number itself is just for the stretch or compress. Now, what's the vertex point? We did this on the warm-up. What's my H value? It's a +5, right? Because insiders lie. So it's a +5. My K value is -3. That stays the same. So go and write 5, -3 for your vertex. Okay? Now, they graphed it, which is fine. So put a point at 5, -3. You already know, because you told me it's going to go downwards. But how do I make that line? Do y'all see how the A value is 1/2? So that means that's my rise over my run. I'm going to rise down, because it's negative, down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. Do you see how you're using the numbers they gave you to get nice points? That way you could use the ruler you would have to make a straight line. Dang. If there's no compression or stretch, it's it's 1 over 1. Yeah. Good question. Now, is this a min or a max? What do you think? Max. Why is it max? It's at the top of the upside down V. Okay. Now, axis of symmetry always starts with a X. Axis of symmetry. X equals, and then what is, again, if you were to draw it, let's see if it draws it first. It does. What X value does that go through? 5. That's the same X value of the vertex, which is right here. So again, this tells you what to write. So X equals that number. X equals 5 is your vertical line. Every time you do an axis of symmetry, you do X equals a number, right? Now, who can tell me, where does it cross the x-axis? The blue thing, not the red dash. The x-axis, this one.
Oh, -3. Oh,
It does not cross it, okay? I'm talking about the blue absolute value does not cross the x-axis up here, right? So sometimes there is no x-intercept, so put none. None you. Now, what about the y-intercept? Since it's going at a slope of 1/2, that is halfway between 5 and 6, so it is -5.5. But don't just write -5.5, because you have to write it as an ordered pair. What's the x, comma, y? What do you think?
0, 5.
0, comma.
5.5.
5.5. Negative 5.5.
So say it all together.
0, negative 5.5.
0, negative 5.5. Very good. Okay. For those few of you who knew Miss Marrero, this was her favorite song. When x is 0, what is y? Y-intercept. Right? So you got to write x equals 0, right? Do it for Miss Marrero. All right. So here we go. 0, negative 5.5. Now, let's talk about domain and range. We did it earlier, kind of. Domain goes forever to the left, forever to the right. So how do we write that? Negative, right? Negative infinity to positive infinity. Or if you use this little weird R shape, that means all real numbers. Okay. Now, if you look on the board here, this is like the real way you write it. It's all like fancy, special font, whatever. So I just draw an extra little line there to make it special. It is what it is. If you just make a nice bold capital R, that's another way to do it. Whatever. Okay. But all real numbers is another way to say negative to positive infinity. What about the range? How far down does it go? Negative infinity. Up to what? Now, check it out. This is the top, right? So is this top 5 or 3? What do you think? Very good. But guess what? Most people tell me it's 5, okay? So, well, again, it's because you have to think X or Y. When you're doing range, look at the Y over here. Don't go up to the X. X is not range, right? So anyways, from negative infinity up to 3, it includes 3, so you got to put a bracket, so it's going to look like this. Okay. Now, I want you to try number 2. I'm going to give you 5 minutes, and we're gonna check and see if you got the right answers, right? All right, here we go. Start. Here we go. Enough wing stop. Example 2. Now, what's my A value? 2, so is that a vertical stretch or compress? Stretch. And that plus 4 shifts which way? Left 4, and the minus 10 goes which way? Down 10. Okay. Now, let's see here. So did y'all get this? So then you can graph it. So if your A value is 2, that means your A value is 2 over 1. That's your rise over run. So if you put your point at 4, 10, your vertex is negative 4, negative 10 down here. And if your A is 2, you go up 2 over 1, put a point, up 2 over 1, put a point, keep that pattern going. Hey. So, if you only had a ruler. Here. Here. Why not?
I'll take it.
No. You cannot take it.
It's just too big.
You're an aviator.
I think I'm as tall as this.
An aviator.
What does that mean?
One who flies. One who makes helicopters.
It doesn't even have holes in it. I wasn't even going to do that.
That's a compliment, because I think you're so crafty, you would figure out a way to make it a helicopter.
Honestly, like, I want to just hit them.
No, wait.
See, that's what I was going to do.
No, see, yeah, that's the other thing we don't want to do.
She gets it.
Okay, yeah, no harming. Now, is that a min or a max?
Max. Why would you name that max?
It's a
Min. Why
minimum.
would you name it min? I would name it
It's a minimum.
min. Is such a weird.
What about axis of symmetry? You always start with what letter? X. Hey. X equals what? X equals negative 4. X-intercepts are what? Now, in this case, do you see how there's 2 x-intercepts? Negative 9 and positive 1. But please remember, you have to put it as an ordered pair. So I'm not going to just write negative 9. How do I write it as an ordered pair? What's the whole thing? What comma what? No.
Wait, is it
Okay,
negative?
sorry. We are doing x-intercept. So this point right here. Sorry. -9, comma 0 is the x-intercept. What about the other one? No. 1, 0. Okay. X before y for your x-intercepts. But now on the y-intercept, that's where it's switched around. What's the y-intercept? 0, -2. Okay. That's where it crosses the y-axis. Okay. Very, very close, but that's it. 0, -2. I'm telling you, the domain is the same. It goes forever both ways. So it's -infinity to positive infinity, or you can write it as the all real numbers. Now the range, how far down does this go? To what? -10 up to infinity, up forever. So you're going to use a bracket first and a parentheses last. Now example 3, you're working backwards. You're starting with the graph, you're going back to the equation. So we're going to just think everything in reverse, okay? Is everyone ready for example 3? All right, here we go. Example 3. Wait, get that out of your hand. Now, hey, get that out of your hand. Hey, so what's the range of this thing, of this graph? We're going from bottom to top. How far down does it go? 3. How far up does it go? Infinity. Okay. These are implied arrowheads, so let's write those real quick. Okay, so from 3 to infinity is the range, and we know the domain is all real numbers from -infinity to positive infinity. Yeah. Who can tell me? What is the y-intercept? Okay, so 5, but how do you say it as an ordered pair?
5,
0, 5. Okay, think of the y-intercept. The y has to be 5, so 0, 5. Does everyone see that there is no x-intercept here, right? Does not cross this line. All right. What's the axis of symmetry? X equals 2 is right on. Is that a max or a min? Is that the top or the bottom of the graph? It's at the bottom, so you call it a minimum, right? Bottom, min. And y'all know the vertex is 2, 3, because y'all can see it right there on the graph. 2 to the right, 3 up, 2, 3. Now, you tell me, has this been vertically stretched or compressed or neither? What do you think? So look at how much it goes up and over. It goes up, let's start at the vertex. It goes up 1 over 1. Up 1 over 1 is actually normal. That's like the parent function. So unless it's different than 1 over 1, okay, then 1 over 1 is not stretched or compressed, okay? So there's no a value. Has it been flipped over? No, so it's not a negative. So the only thing that changed is a shift. Shifted to the right, shifted up. So that means it's been shifted right 2, up 3. If it's been flipped over, you just make sure there's a negative out front for the equation. So y'all tell me, how should I write this equation if it's right 2, which is going to be a lie, and then up 3? So I'll start. It's y equals vertical line x. How do I put right 2? What number? Is it plus or minus? Okay, because it's a lie. So -2. And then up 3 is what? Plus 3. Let's see if that's what they got. Ta-da! Y'all are pros. Y'all are going to do great on the quiz on Friday and the assignment that I'm going to give you right now. You'll have time tomorrow as well to do this. So I'm going to pass it out. Let's knock out 3.2, baby.